Okay, problem number 12. It's a system of nonlinear equations. And what I'm going to try to do is solve for x and y. All right? So I'm going to go to the whiteboard because I really can't fit this on this PDF file. So I'm going to go to the whiteboard. And what I'm going to do is just start simplifying the equations one at a time. And that first equation, the first thing I see in that first equation is I have to square the 3x plus 4y. And that would give me 9x squared plus 16y squared plus 24xy. And then I've got to subtract away. Let's see what you got to do. 6x times 6x, that's 36x squared. And then, you get, let's see, 30xy minus 6xy, which is 24xy. And then you get minus 5y squared. And this is all equal to 57. And again, I'm just working on the first equation. What do I see there? Let's kind of add it together. And, the xy terms disappear. That's good news. And then you get 21 y squared. Write that down. All right, so that's done. And then you're going to get, let's see, minus 27 x squared equals 57. All right, so let's take a look at it. And I'm saying divisible by 3 now. So what are you going to get? 7y squared minus 9x squared. And 3 goes into 57 19 times. So I'm going to say the first equation is as simple as it gets. I'm going to start to erase. That's the first equation. And now let's write the second equation down. And the second equation is 52y squared plus 17x squared is equal to 225. Well, again, we're really kind of back down to the same old, same old. And then the question is, what do you want to do to eliminate? And there's many things you could do. Let me take a look at it. I can say 17 times the first equation and 9 times the second equation. Right, I realize some students are going to say they want to use a calculator. There's nothing wrong with that. What I'm going to do is, just going to do the arithmetic. And let's see, 17 times 7. Let me write this over here. That's 70 and 49. That's going to be 119 y squared. Minus, I don't really need to write it down. I'm just going to write down 17 times 9 x squared. Let me erase her out. Erase this over here. Get some more arithmetic. And I'm going to do 17 times 19 now. Well, I get 190. 10 times 19. 7 times 10, 70. 7 times 9, 63. Let's see. 9 and 7, 16. 22. 323. Get my eraser out. Erase my arithmetic. Don't need it anymore. Keep moving. Well, I got to do 9 times 52. Well, 9 times 50 is 450. And 9 times 2 is 18. So what do you get? You get 468 y squared plus 17 times 9 x squared. Nope, I don't need to multiply that out. But I do need to do the 9 times 225, all right? So 9 times 225, they're big numbers, 1,800, 180, and 45. 5, 12, 10, 2, 2025. What are you going to do now? Add them together. Let me erase this over here. Adding them together, let's take a look. 119 and 468. Let's see what you get. 17, 678, 587. I'm going to add those two together. That's not so bad. 2, whoops, sorry about that. 2, 3, 4, 8. All right, so now the question is, what do you do now? And I'm kind of looking at it, and I guess I got to go through some work here, don't I? And I'll put this down, 587 into 2, 3, 4, 8. Let's see, 4 times 7 is 28, right? Four times 8, 32, 33, 34. That would be 23. Remainder 0. So what do you get here? Y squared is equal to 4. That means y is equal to plus or minus 2. I'm going to erase my work up here. All right? So the big question is, what are you going to do now? Well, I got 2 y's, and let me write this down. They're going to be ordered pairs. So 2 and minus 2 for the y. And the question is, how are you going to get the x? Well, I'm kind of looking around for something easy to deal with, and I'm going to say this looks like the easiest one for me to deal with. All right? So if y is, plus or minus 2, that seems pretty easy to me, because then you get 7 times 4, whether it's 2 or minus 2. And that's going to be 28. Minus 9x squared equals 19. I'm going to subtract 28 from both sides, and you would get minus 9, or you would get x squared is equal to 1, or x equals plus or minus 1. I'm going to write that down now. So 1 or minus 1, 1 or minus 1. All right, these are my 4 answers I got. Now, granted, you really should go back to the original system and check that. I want to claim in the key, though, and it's something you probably want to pay a little attention to. In the key, we write the answers down for you, and we also put a graph down for you. And we put the graph of the original system down. And if you look at the graph of the original system, what you're going to see is, 2 graphs where there's 4 points of intersection clearly being indicated. And again, as a reminder, Wells really did not construct graphs for these problems over here. The number one reason, I believe, was they're really difficult to graph. They really are. But certainly with machines are pretty easy to do. And it's really kind of the domain of pre-calculus anyway to graph those. All right? So we're done. Again, if you need to reach out to me, I think you know my name by now. My email address is Bannon. That's B as in boy, A, the @ symbol, NNON.US. Again, if I'm not overwhelmed, I'll certainly respond to you. Thank you so much for paying attention, though.